Now basically with this video, doesn't matter what machine you're using, what machine you own, doesn't matter what it is, what make and model, doesn't matter if it's engine drive or electric machine, doesn't matter if you're in a shop, out the field, on the pipeline, doesn't matter where you are. You see, you could have a Cross Country 300, I'll show you how to set that machine. You have a Vantage, you have an SA 500, I'll show you how to set that machine. You have a Classic 3, 3D or 300D, Welding D300K, it's all the same machine. You have an SA 300 with continuous current control, I'll show you how to set that machine. Does your machine have the custom mark, 200D, 300D with the Kubotas? I'll show you how to set that. You have a Commander 400, I'll show you how to set that. You have a SAM 400, a SAM 650, I'll show you how to set that. Do you have a Miller XMT? I'll show you how to set that. You do have a Miller Air Pak, Trailblazer 44D, any of these machines from 1996, Do you have anything in here? I'll show you how to set that. There's some more machines to look at here. Nice SA 500, 200D. You see the SA 400i is not in any of these books because these are American books, but no matter what it is, I'll show you how to set it. So this is that video. This video is going to show you how to set the ones with the dials, continuous current control, the one with custom mark adjustment, and whatever else you could imagine. This video will show you how to set it. So basically in this video I'm going to show you the difference between the inverters, the generators, and how to set your machine, and basically the differences and how to figure out where to set your machine. So this is your typical inverter. This is a Vantage 400. This is your amperage. This is for adjusting the amperage, and this is for adjusting your voltage. When you have a remote, when you adjust the current on the remote, you are adjusting the amperage here. Your remote, you do not have any control over this at all. So this is your voltage and this is your amperage. This is all arc characteristics. Everything here is arc characteristics. Doesn't matter that it has 0 or -6, +6, whatever. It's more voltage, adding more voltage on this side and adding less voltage on this side. This is all arc characteristics. And on these inverters here, whenever you adjust the remote, it's always you're adjusting the amperage. Always remember that. You're adjusting the amperage on an inverter. Now this machine is a generator. It's a 1956 short hood. This is your amperage range, and this is your voltage. When you're adjusting the remote, or when you go and change your welding current, you would change the voltage. That's the difference between an inverter and a generator, is that every time you change the current on the generator, you're changing the voltage, and the voltage influences your amperage range. And on an inverter, when you adjust the current, you're adjusting the amperage and you do not touch the voltage. You have no control over the voltage in terms of adjustability. Now, if I go into this machine here, this is all arc characteristics. Say I like this arc characteristic right here. Okay, my arc characteristic is locked. Doesn't matter what I do, what I adjust this to, does not matter. My arc characteristics remain the same because I do not touch the voltage. It's the same as me going, okay, this thing here, I like this arc characteristic. I'm gonna go walk over here. This is an SA 400. I'm gonna match up to maybe I like the arc characteristics of what was offered on the inverter style. So I'm going to set to whatever my arc characteristic was, and then now this is basically the same as me adjusting an inverter, treating a generator as if it's an inverter. So I'm going to choose my arc characteristics, the same as a voltage. This is a voltage right here. This is a voltage right here. This is a voltage right here. This is arc characteristics. I like this arc characteristic. This is my arc characteristics. This is my arc characteristics. This is voltage. Say I like that one. I go over here and all I do is when I adjust the welding current, I'm just going to adjust the amperage here. That's basically the same as treating this generator as if it's an inverter. Now, generators, see, generators don't work this way. They don't have this voltage set and then I'm adjusting the current. No, when you're adjusting the remote, usually you're within a range on the amperage. This is a generator. You're always within a range on the amperage. You're always adjusting the voltage, and the voltage, you know, on the remote influences the amperage range. So when you increase RPMs, when you increase the voltage, it increases or decreases the amperage, but it changes the volt amp curve. I'll get to that in a second. Same with this machine. This is a generator. When you adjust whatever gear, this is not continuous current control, this is dials. When you adjust the voltage on the remote and everything, it influences the amperage range. So this is the different dials, different gears. This is a gear machine, and this is continuous current control. See, I can adjust it. I don't have dials. I can adjust it anywhere I want. Same with this machine. I can adjust it anywhere I want. These are non-gear machines. This is continuous current control. This is all continuous current control. I can adjust it wherever I want. And this is voltage. Now, when I go back to an inverter, you see this is basically what I'm getting here. Let's see, when you add more voltage to the weld puddle, so I'm adding a little bit more voltage to the weld puddle, you see? This is all arc cartridges. I'm going to add more voltage to the weld puddle. Same as here, I'm going to add more voltage to the weld puddle. Okay? And I'm going to talk about volt amp curves and everything here in a second. And gears and everything in relation on the generators. Volt amp curve, we're going to add more voltage to the puddle. This is kind of where you're going to expect. You're going to get a wetter puddle, you're going to get less drive, you're going to get a softer arc, you're going to get less dig, you're going to get less crater, you're going to get maybe a globular deposition, you're going to get less push, going to be a more passive arc. These are all words to describe adding more voltage to the puddle. Doesn't matter what it is, SA 300, 300D, SA 400, SA 500, inverter, like a Miller, doesn't matter. XMT does not matter. So I'm going to add more, I'm going to add less voltage. I'm going to take the voltage away, have more less voltage and more amperage head ratio, so less voltage here. That's what I'm going to expect. I'm going to expect a drier puddle, more drive, crisp, stiffer arc, more dig, more weld, let's see, more crater, short circuit mode, more push, more aggressive arc. So basically you're going to see the contrast. So more voltage in the puddle, you're going to wet. Take the voltage away, it's going to be dry. More voltage in the puddle is less drive. Less voltage, more drive. More voltage, softer arc. Less voltage, crisper, stiff arc. So basically it's going to be a contrast. So basically, since this is all arc characteristics, when I want the change of my, when I can visualize what kind of weld puddle I want, how dry it is, what kind of dig I want, everything, I'm going to go up to my machine here and I can start fiddling with it until I see I'm over here. Well, I want my weld puddle to be a little bit drier, a little bit more stiffer, a little bit more dig. I want a little bit, you know, I want a little bit bigger crater. I'm going to start adjusting this to less voltage size. Now with these machines here, let's see here, well, there goes that. This is the volt amp curve here. So look at the volt amp curve here. These are two different volt amp curves. Now you have 5 overlapping ranges on these. Well, if it's a 5-gear machine, you have 5 overlapping ranges. It's a 4-gear machine to 4 overlapping ranges. The gear's a little bit longer on the short hoods. But if you see, this one here is basically this is going to be a more amperage, so a higher gear range, lower voltage. And this is going to be a lower amperage range, higher voltage. This is the same as going up to a, say, a 2nd gear 70 is the same exact amperage, is a higher gear, so it's like a lower gear 70, a lower gear 70, it doesn't matter what it is, a lower gear, a lower gear, a lower gear, you know, a lower gear, okay, 70 is the same amperage as a higher gear 40,
higher gear 40, higher gear 40. The volt amp curve is different. So basically a lower gear, see, a lower amperage range and a higher voltage range is basically me going, like, say I want second gear and 70. That's a lower gear, higher voltage. I'm gonna get a volt amp curve very similar to this. This idea. Now, I like the amperage. I want a little bit more dig, more drive. I want these kind of characteristics. Maybe I want a little bit more drive. I want kind of a stiffer arc, a little bit more dig, you know, maybe a bigger crater, a little bit more aggressive arc, you know, because maybe I'm not happy with how wet it is, or it doesn't have enough drive for what I need. It's a little bit too soft, a little bit less dig, or a little bit less crater, whatever, you know. So I'm going to go up to this machine and I'm going to go up to a higher gear and I'm going to drop the voltage down. So now I have same amperage between the two, but I have less voltage. So now I got these characteristics. I've got a drier puddle, got more drive, stiffer arc, more dig, more crater, more of a short circuit mode, more push, more aggressive. And now I got this kind of volt amp curve where I have more amperage range and less voltage. So basically the difference between the two here, what you need to know is that when I manipulate the arc length, my immediate amperage and voltage are going to more dramatically change. So as you can see, when I adjust the my arc length, you see it changes more rapidly. On the amperage it changes, and on the voltage it changes. Whereas when I go to the lower gear and higher, lower amperage range and higher voltage range, like a second gear and 70, then basically when I manipulate the arc length, my relative immediate amperage and voltage remain consistent. My heat remains consistent. So if I'm, say, TIG welding, then I want to be, say, in a lower gear and I want my voltage higher, and the reason being is because when I manipulate the manipulate the arc length, my immediate amperage and voltage do not change dramatically. Whereas if I'm welding like a heavy wall pipe, I want, you know, with 7018, I want my voltage as low as possible, and I want, when I manipulate the arc length, when I hold a tight arc on the sides, I want my amperage to spike off, my burn off rate to spike up, my voltage drop off. So I can hold a tight arc and push, the burn off rate spikes up, and then go give a little arc length across the middle, so my amperage and voltage, the voltage comes back in, makes it fluid from the one side to the other, and I go over the side and I hold a tight arc, and my amperage spikes up, my burn off rate spikes up, my voltage drops off the chill puddle. So with the drop in voltage, the opposing side I just left is going to solidify, so I can hold a tight arc here, allow burn off rate, a spike of amperage, voltage drops off, I can go back over to the other side here and deposit metal. Whereas a lot of guys will find that if you're in, say like higher voltage, well then the arc characteristics is softer. Sometimes I'll almost have to hover over the weld puddle, because if it touches, maybe it might go out momentarily and reignite the arc, and they'll get porosity there. You know, and it doesn't stack as much. 7018 uphand, it doesn't stack as much, just because the voltage remains, keeps the puddle liquid over here, and you're over here, and it's still liquid over here, and then it's liquid weld puddle, and you go back to the other side, and you're depositing your liquid weld puddle onto previously deposited metal that's still kind of liquid, you know. So that's why you adjust one adjustment. Now, however, if you go to this machine here, say, actually let's use this one's easier to read. Say you want as low voltage as possible, and you want so much dig and drive and everything, and you're gonna stack metal, you're gonna pour it in there. So you're gonna go to say you're burning 1/8 718 or 532 718. So I'm gonna go as high as amperage range as I possibly can, and then go as low as voltage as I possibly can, and this is gonna be perfect for burning 1/8. Now the problem is that you're gonna end up, for every 1/3 of metal you deposit into the puddle or into the pipe, it's going to spit and spatter out 2/3 of your puddle, and it's just going to be like spatter and globs, and you're not going to get anywhere in life. So basically you kind of have to compensate, you have to add a little more liquid, you know, You have to drop the amperage range a little bit here. You add a little bit more liquid so that when the weld puddle hits the pipe, it's not going to be globbing out and everything. It's going to go on there nice and at least stick to something. Now we're going to come back to the inverters here. Say for example, say you have a Miller XMT. You're at +7. You're doing a downhand route, and you notice that the weld puddle is so dry that when you're progressing at the speed you're progressing, the puddle solidifies up here, opens a little window, and then you keep going, and basically your puddle solidifies too fast. So what you need to do, you need to add a little bit of liquidness to your weld puddle, and you just maybe add a little more liquid. You add more voltage basically. So that's basically how this stuff works. Or if you're doing a fill pass, say you're running an inverter, you're doing a fill pass, say you know, you don't want a big size crater because you're filling, you don't have to clean out a lot of stuff. It's not like the hot pass, it's a fill pass. You don't want to open a big crater because it cuts down the amount of time, because you open a crater, your weld puddle has to fill that crater, and then you have to move up, deposit some metal. Here you want less crater size, so you're going to drop down voltage here, so it's going to be the crater that you're digging to the parent material you're welding on. The crater is going to be smaller, so the weld puddle is going to go on there like a glob. It's not going to chew and dig in like it would over here. Less voltage, it's going to be less digging, so it's going to be like more of a glob. Like -4 would be more of a globber, whereas +2, +4 would be more of like a short circuit mode. So if you have a big crater and you want to fill faster, add a little bit more voltage into the weld puddle. It's going to make your puddle a lot more liquid. Now the other thing to notice too is that the 200D, 300Ds with the Kubotas, you see they have a little custom arc adjustment here for adjusting your RPMs of your within 150 RPMs. Basically it's the same as me going over here and say, okay, well there we go. Okay, and I'm going to adjust it here. There we go. I'm just adjusting the voltage basically. That's all that is. It's adjusting the voltage. Maybe a little bit drier. Okay, go over here. A little bit wetter. Okay, over here. See, I can't do that. What I have to do in this is I have to hold the rack. So if I like this setting here, maybe I like this setting for the root. I want a little bit more liquid. Well, I basically have to roll the rack just a little bit and add a little bit more voltage to this. Whereas if I have, you know, a machine with a continuous current control, this is the same as SAE, or yeah, SAE 300s. I used to own one of those. Here's a one from the 1946. Let's say it's like, okay, this is the SAE 300s is completely opposite, but this is the same idea, the continuous current control. You're going to go up to 150 and say you're at 60%. Okay, so I want a little bit. You know, I want more voltage basically. So basically, what I'm going to do on those SAE 300s, when you guys have those SAE 300s, you want more voltage in your weld puddle. You go down a gear and you go up 20. Same amperage, the voltage is different. More voltage, different volt ampere. When you now go back to baseline of 150 and 60%. Now you want more digging arc, more stiffer arc characteristics. Go up a gear and down 20. So now you're at 40%. You're up a gear from 150 or whatever it was, and now you're down 40%, or down 20%. So if you always have a baseline, if this is the SAE 300s, because I know a lot of guys on Instagram have, and they don't know how to set their machine, and these dials are opposite. 150, the amperage range is on this side. 150 here, the fine current is on this side. The arc characteristics, that's the way you think about it, arc characteristics is 60%. Just go down a gear and up 20, or up a gear and down 20. See, that changes quite a lot of things. It makes very noticeable changes. But when you have these continuous current controls, when you don't have that custom arc, that's one way to get around it, is that on these dials here, you're stuck at gear. You can't go in between ranges. You're stuck at a dial. You know, you can't adjust nothing unless you roll your rack. Whereas I can go over to this machine here. Say I'm in third gear. Say for example, say this is third gear right here. Okay, on the other machine. Say this is third. Imagine this as a dial machine. Okay, say it's a third gear, and this is my arc characteristics, my fine current adjustment. Well, on a dial machine, I'm in trouble here. Gotta roll the rack. But or if I had the continuous current control, or sorry, custom arc adjustment to adjust the RPMs, then I can get away with little things. But because this is continuous current control, I can add a little bit here, go up in amperage range, and I can drop the voltage, a little bit stiffer arc. You know, I can get these kind of characteristics here. You know, these kind of things here. Whereas, you know, I can go down in amperage range just a little bit, and then go up in the voltage, and my amperage remains consistent. But I just played with the volt and amperage ratio, and now I got these kind of settings. So basically that's how you adjust these machines here. That's all it is. So this SA400 from 1974, this is just your amperage range, this is just your amperage, and this is just your voltage. And it's always a ratio. You're playing with a ratio of amperage and voltage. Just a ratio, amperage, voltage. Amperage range, voltage is always a ratio of the amperage and voltage. This is your amperage, this is your voltage, this is your arc characteristics. These inverters, when you adjust the remote, you're always adjusting the amperage, and your voltage, your arc characteristics always remain consistent. On a generator, when you adjust the remote, your amperage range always remains consistent. You adjust the voltage, it changes the volt amp curve. Voltage, influence of voltage, you know, influence of changing the arc length, adjust the immediate amperage of voltage. So this is basically the difference between the two, and this is basically how you set these machines. The last thing here is arc gouge mode. It's nice for burning 1/4 inch, 718. Arc gouge mode is pretty much the same as a +10. You can root, you can take in everything else on this mode, but the problem is that the puddle solidifies too fast. So if you're roll welding, okay, if you're roll welding, you're dragging the puddle along and it solidifies too quick on the root. That's no good. You need to add a little bit more liquidness. You go back to downhill mode and you add a little bit some liquidness. So when you're traveling, your weld puddle is liquid enough and it follows you along. So that's basically, you know, arc gouge mode, downhill mode.